are going to actually get back into some trig integrals today. They should be in your notes somewhere. If you don't remember what they are, we'll go back through some of them. But it's still definite integrals. It says evaluate the definite integral. And actually, handy dandy might be handy today. We could run into some identities on the back of handy dandy. So if you've got yours, you might want to take it out. If not, I've got some extra copies up here. Just gave handy dandy to trig this morning, so it was a pretty good day in trig. Now they know about handy dandy and they can use it as well. So first one that we're going to do, example 1, we're integrating from 0 to pi over 2, and it's 3 cosine of x dx. 3 cosine of x dx. Now, it is trig, but remember the multiple rule here for integration. Anytime you've got a number in front of your function, the number pretty much just stays there while you integrate the function. So, does anybody remember what you get if you integrate cosine? Been a little while. You're thinking, is it sine? Is it negative sine? It's just sine. Yeah, derivative of cosine was negative sine. So that's always kind of how I remember it. It's sort of the opposite. The integral of cosine is just positive sine. That's the integration part. Now I just have to worry about plugging in the upper bound and the lower bound. And you could actually use handy dandy for this part as well. I always want to plug in the upper bound first. So that's what it looks like plugging in the pi over 2 minus 3 sine of 0. And here's how I'll use handy dandy. On handy dandy, you should be able to see what sine of pi over 2 is. I'm using that table at the very bottom. Sine of pi over 2 is equal to 1. So right here, it's like taking 3 times 1 minus 3 times sine of 0. Something else I can get from that table. Sine of 0 is 0. So I'm just taking 3 minus 0, which is 3. So that would be that. Now, you could probably also use your calculator to type in these trig values right here. Most of the time, I stick to handy dandy if I can, because we're going to run into like secant later, maybe even cosecant, and those are kind of hard to type into your calculator. So again, use handy dandy for those if you can. All right, let's try another one. Example 2. Got 5 of them today. We're integrating from 0 to pi, and it's 4 minus sine of x dx. Parentheses are up there just kind of as a technicality because you want all of that to get integrated with respect to x. Basically, I'm still going to integrate each part separately. You don't have to keep it together because the parentheses are there. If I integrate 4 with respect to x, it'll just be 4x. And then I have to subtract what I get when I integrate sine of x. What is the integral of sine? Negative cosine. All the negatives are jumbled up here, but that is negative cosine, and I'll probably actually make that look better before I plug in my numbers. Let's just turn that into 4x plus cosine of x. And again, it's going from 0 to pi. So plugging in pi first, one of the most common mistakes, forgetting to plug in the upper bound first. Wherever I see x, I replace it with pi. So 4 pi plus cosine of pi, I'll figure out what that is here in a second, minus, I'm just going to put this in parentheses to keep it all together, 4 times 0, that's just going to be 0, plus cosine of 0. So I'll probably leave 4 pi alone for just a second, and then I'm looking at handy dandy, cosine of pi is -1. So I'm not going to put plus -1, I'll just put -1 right there. And then in parentheses, let me think about this for a second, cosine of 0 is the same as 1. So this is basically like 0 plus 1, which is 1, but there is a minus sign in front. So we're taking 4 pi minus 1 minus 1, so we could actually just write that as 4 pi minus 2. It wouldn't be as exact with a decimal, so every now and then you may have to just leave your answer in terms of pi. Okie doke. Any questions on that one? Starting off kind of simple here. Let's keep on rolling. Number 3, I'm integrating from pi over 6 to pi over 4. And the integrand is secant squared of x minus tangent squared of x dx. All right. Now, you may or may not have your list of trig integrals in front of you, but there is a little bit of an issue here. We don't have an integral for secant squared, and we don't have an integral for tangent squared. So I've got secant squared actually, but tangent squared would be the issue. That one would probably be fine, but we don't have an integral matching up to tangent squared. So this is where I start to think about other things that I could do to make this a little bit easier to integrate. And I'm actually going to use the back of Handy Dandy for this. My brain, anytime I see trig functions that are squared and I'm trying to rewrite them, my brain goes right to the Pythagorean identities. I'm looking for secant squared minus tangent squared. Anybody see what that is equal to? 1. Now, your answer is not 1. Let's make sure that's clear. The answer is not 1, but that is my integrand now. The only thing I'm integrating is 1. So what do you get if you integrate 1 with respect to x? Just x. And now we have to take that from pi over 6 to pi over 4. So plug in the pi over 4 first. I've got pi over 4 minus pi over 6. Now, like I said earlier, it's probably best if you try to keep it in terms of pi. So you may have to get some common denominators. LCD is 12. I'll multiply that by 3 and that by 2. So 3 pi over 12 minus 2 pi over 12. That would just be a 1 pi over 12. So that would be our answer for number 3. Handy dandy. Every now and then you may run into something that can be rewritten using an identity. Okie doke. I've just got a couple more here, so stop me if you have any questions. These usually aren't too bad. They tend to work out kind of nice. Number 4, the bounds are the same. We're going from pi over 6 to pi over 4. And now it is secant of x times secant of x plus tangent of x dx. All right. Now, we've actually run into this a time or two before. There is going to be some rewriting to do in this problem. Anybody know what to do first? Yeah, very good. Distribute that secant of x. And once you do that, it actually works out really nicely, and it matches up to some of our trig integrals exactly. That'll turn into secant squared of x plus secant of x tangent of x dx. All right, now if you go back to number 3, I couldn't do that integral at the beginning because I knew what secant squared was. That was a good integral, but tangent squared was not. This problem though, both of those match up to integrals exactly. Anybody remember what you get if you integrate secant squared? Tangent of x, very good. And what about integrating secant of x, tangent of x? Secant of x. It's kind of almost backwards from those derivatives that we had. So, plug in the pi over 4 first. That will be tangent of pi over 4 plus secant of pi over 4 minus, I'm putting this in parentheses, this will be a quantity, tangent of pi over 6 and then plus secant of pi over 6. So I'll probably go back to handy dandy to help me a little bit, at least at the beginning. Tangent of pi over 4 is 1. You could type that into your calculator pretty easily to get back the 1. But like I said earlier, secant is a little more complicated to type in. It'd have to be like 1 over cosine of pi over 4. I don't want to worry about that. So I'm doing my handy dandy here. That secant of pi over 4, that's radical 2. Now I'll probably go ahead and distribute this minus. If I subtract tangent of pi over 6, then that means I'm subtracting radical 3 over 3. And then secant of pi over 6, that is 2 radical 3 over 3. And again, that will have a minus in front since we had to distribute. Now, if it's in terms of pi, you can keep it in terms of pi and it works out pretty nicely. When you get a whole bunch of radicals like this, a decimal might be our best bet to get this simplified. So I'll keep the 1 there, and I'm just going to type in each one separately. Square root of 2, and it doesn't really bother me how many decimal places you leave. I think I left 2, but the more the merrier, I guess. 1.41 for that. Now radical 3 over 3. Be careful when you type that in. That's like a 0.58. So I'm subtracting 0.58. I want to show you that real quick on my calculator. If your calculator does it like mine and it puts the radical 3 under the square root, you have to hit the right arrow to jump out of that before you divide by 3, because the 3 was not under the square root. If your calculator sets up parentheses, close the parentheses right after the first 3 before you hit divided by 3, and then that'll give you the correct value. Now, I might as well keep my calculator up here. I need 2 radical 3 over 3. It's probably all right just to do it like that. I'm going to say that's about a 1.15. So I was subtracting that. Now I just need to kind of type all of that in. And go ahead.
Can you simplify the back two? Like from the get-go, the square root of 3 over 3 minus the 2 square root of 3 over 3?
You could, yes.
Would
If
that
you,
just be the square root of 3?
it would be negative. Yes, that would be fine if you wanted to do that. That will work. So I've got 1.1 or 1 plus 1.14, 1.41, too many ones, minus 0.58 minus 1.15. Okay, think I got it. I got a 0.68. So 68 hundredths. That would be our answer. That's the area between that function, whatever that would look like, and the x-axis. Okie doke. Any questions about that one? Not too bad. Last one here. This actually works out pretty nicely too. Number 5. We're integrating from negative pi over 4 to positive pi over 4. And it is secant squared of x dx. Now I'm going to pull something from trig on you with this problem. But first of all, I can integrate that right off the bat. Integrating secant squared of x, you get tangent of x. And I just now need to plug in the upper bound and the lower bound. So this is going to be tangent of pi over 4 minus tangent of negative pi over 4. Now, handy dandy should be able to help me with at least this first one. Tangent of pi over 4 is 1. Now, when I come back here to find tangent of negative pi over 4, handy dandy does not give me any negative values. So you've got a couple options here. One option, which is probably not the one you're going to take, but one option would be to find a positive coterminal angle for negative pi over 4. Anybody remember how we did that? Add 2 pi. You could do that right here. You would end up adding like 8 pi over 4 once you get common denominators. Then that should be something you could find on Handy Dandy. But actually, I think this is something we could probably also type into our calculator. That's probably the shorter way to do it. Make sure you are in radian mode. I don't know, so I'm going to check. Oh, says it up there. I am in radians, so I'm good. And I just need tangent of negative pi over 4. Probably don't have to end those parentheses there, but that is negative 1. Now be careful, once you plug in that negative 1, you are actually subtracting the negative 1. So it turns into 1 plus 1, which is 2. Make sure you didn't put answer of 0. 1 minus negative 1 is 2. All right, any questions on that? Good stuff here. Okie doke. I'll go ahead and put the assignment up. It is C79 from page 328. Got like 20 minutes. You can probably finish this in class, I would say. It's 27 to 33. 27 to 33.